Good morning, class. Today we're doing lesson number 6 on igneous rock and the rock cycle. So today's going to be the last new material we're going to cover for the rock cycle. We're going to finish up the 3 types of rocks by looking at igneous, and then we're going to look at the rock cycle in more detail, knowing more about rocks than when we first looked at it in the first lesson. So igneous rocks form in maybe the most straightforward way. When magma cools, you get igneous rock. But this can lead to some very interesting rocks, especially for scientists. So the nice thing about igneous rock is they give us an insight into the makeup of the mantle. So when magma comes onto the surface of Earth, it cracks through in a volcano or a magma plume, and you get molten rock from the mantle spills up onto the top of Earth's crust. And when it cools, that magma forms igneous rock. And we can look at this rock and it will tell us directly about what material the mantle is made up of. So what type of elements are in the mantle. We can also, based on analyzing this rocks, we can look at the temperature of the mantle, the pressure in the mantle, and a whole bunch of other information as we look into more and more tests that we can perform on igneous rock. So I'd say the most simple rocks that form, they give us the most information about what's underneath our crust. So we can break igneous rock into 2 main groups. There's intrusive and extrusive igneous rock. First, let's look at intrusive rock. So igneous rock forms when magma cools. This can happen on top of Earth's crust or inside Earth's crust. So intrusive igneous rock is when inside Earth's crust, you get a pocket of magma that's surrounded by formed or pre-existing rock. This is non-molten rock. And over time, it slowly cools as it transfers heat into this non-molten rock, into this pre-formed rock, and so it loses heat itself, passes a little bit of heat off to the rock, but not enough to melt it. And over time, so slowly, it will cool, forming igneous rock inside Earth's crust. Because this process takes a while, the rock's going to look different than if it cooled quickly. So we're going to get coarse or large grains. By grains, we mean there's going to be different parts of the rock that have a different makeup. They're going to look different. So these grains are going to be like speckles. Generally 2 different colors, sometimes it's more. So large speckles, so like salt and pepper, but bigger bits. So some white, some black. And they're going to be larger bits. So from like maybe this big all the way to this big, we get groups of where you have speckling in the rock. So you have different colors and different makeups. And we call this coarse grain. An example of this is granite. For extrusive, this is when the rock, magma spills onto Earth's crust and cools out in the open. And this cooling is done very quickly. As it cools quickly, we get smaller crystals forming. And what this leads to is smaller grains. So we get the same kind of pattern, you get speckling, so different colors, but it's much smaller. So sometimes it can be so small it's hard to see, it just looks like it's one neutral color between the 2 different colors that it actually is, but we get smaller grains. If it cools really quickly, an extreme example of this would be glass. So glass cools really quickly and we get really, really, really small grains, and it all just like one very clear color or very shiny color. So example of this would be like obsidian. You can't see any grains in there. You can't see any multiple colors because they formed so small. Okay, so that's pretty much igneous rock. Igneous rock, again, is very important because it gives us insight into what's beneath Earth's crust. Because we can't really dig into the mantle. It's not feasible for us to do that. It's so far down. So igneous rock is really our only insight into what the mantle is made up of. We can also look at new forming oceanic plates, but these are under a ton of water and are much harder to analyze than igneous rock. So I'll come back to the bottom of this page after, but let's first look at the rock cycle on the next page. So I'm just trying to see if I can rotate my screen here. Perfect, okay. So I found this image and it gives us a really detailed look at the rock cycle. So let's look at where we started today, igneous rock. So igneous rock can transform into sedimentary rock or metamorphic rock. So if igneous rock gets buried or gets pushed down in towards Earth's crust or even towards the mantle through a subduction zone or being buried by more rock, it will heat up and it will be put under a ton of pressure, and that can form it directly from igneous rock into metamorphic rock. As I'm just saying this, one thing that came to mind is the difference between igneous rock and metamorphic rock. With metamorphic rock, there's not the melting. When a rock becomes metamorphic rock, it does not melt back down. It gets changed by heat and pressure, but not enough heat to melt it. As soon as the rock gets melted, it's going to form igneous rock. So with metamorphic, there is no melting of the rock. All right, so back to this. So igneous rock, through heat and pressure, but not enough heat to melt it, can get transformed into metamorphic rock. It can also get weathered down. As it gets weathered down, it breaks down into sediments. And these sediments get compacted and form sedimentary rock. Lastly, igneous rock can get melted down, form into magma, and then cool back into igneous rock again. So it can become igneous rock once again. But this would be a brand new rock. So the aging process gets reset when it melts. So moving on to sedimentary rock. Sedimentary rock it doesn't have a wide range. It can't just form into igneous rock, but it does get weathered down and erodes, forming sediment, and that's going to form new sedimentary rock. So it can kind of reform into different sedimentary rock. It can also get buried and heat and get put under a ton of pressure and form metamorphic rock. Sedimentary rock cannot, or very, very rarely, will melt directly and form igneous rock. Based on the way sedimentary rock forms, it's not going to be in a position to melt. Okay, looking at metamorphic rock. Metamorphic rock can't form into itself again. Because it's already been put under heat and pressure, metamorphic rock cannot get put under new heat and pressure and will not change. It will remain the rock it is. So it can either melt, become magma, and form into igneous rock, or it can get eroded, forming sediments, forming into sedimentary rock. Looking at the rock cycle as a whole, this happens over a long period of time. Most rocks on Earth you're going to find are going to be in the 10 million years old range. We can find rocks that are almost as old as Earth at like 3 billion years old. But these rocks are hard to find because generally over time, these rocks have gone through the rock cycle. They change their chemical makeup by getting melted, by becoming sediment, getting broken down, having new particles built into it as it's a sedimentary rock, new particles built in, compressed into a new rock. Or it's going to get changed by being put under heat and pressure, either by plates colliding or being pushed deep into Earth's crust and forming a new type of rock. So it's very rarely that we will find these really old rocks. When we do find these really old rocks, we're generally looking for igneous rock. As Earth cooled, pretty much all the rock on the beginning, when Earth was first forming new rocks, cooled from hot magma. So all these old rocks we're looking for are going to be igneous rock. And over time, we get sedimentary rock and metamorphic rock. Sedimentary rock is really good for looking into Earth's past, looking into what happened or what was the chemical makeup of the environment, what was the chemical makeup of some of the animals that were living at the time when that rock was formed. So we can age the rock when sedimentary rock was formed, and then we can look at some of the biological components or some of the chemical components in the rock to give us an idea of how the atmosphere was and what type of life was on Earth at that point that that rock formed. So over a long period of time, the rocks are going to move around in this rock cycle and get replenished. So at no point are we losing any rocks on Earth. They're just getting changed based on energy. Energy is put into the rocks to either weather it down, to remelt it, or to heat and add pressure to it. The energy that gets pushed into it, it changes the makeup of the rock. And it's a constant cycle, so there's no energy being lost. The energy just changes its form. Either the mass of the rock is going to increase, or the mass of the rock is going to decrease, and energy is going to be given off. What else do I want to say on this? I think that's everything. So let's look back at this first page here. So that kind of ties up the rock cycle. We could definitely go into more detail. I just want to keep this kind of a shorter bit because we're losing a little bit of class time, as we're only doing 3 hours a week, as well as I want to spend more time on climate change. So on Friday, I'm not going to have a new lesson for you, but what I'm going to have is I'm going to produce a video where I'm going to demonstrate and try to introduce a project I want you to work on for weathering. So try to finish up the questions. I think I'm going to have 4 questions for this lesson, as well as the questions, the past questions this week and last week. Try to get them done by Friday so that on Friday you're ready to work on the project. The project will likely take about a week. Next week I will have new lessons for you. They might just be a bit smaller so you have more time to work on the project. As for like tests and quizzes, I don't want to do any formal tests or quizzes. I'm happy with how the assignments are going so far. The projects will be about as formal assessment as I will get in this course. If you have any questions, please let me know. Email me. If some of you are feeling like you want more work or you're bored at home, I can get a lot of you in very different situations, but if you feel like you want a bit more, I have some bonus projects that are available if you want extra more to work on. So please just send me an email and be like, hey, I want a little bit extra work. What's the bonus question like or bonus project like? And I'm happy to give you some options. Okay. Have a good rest of the day.